Assalamualaikum and hi everyone. Today we are going to learn about alpha, beta and gamma. For today's lesson, we are only cover for one learning outcome, which is 6.1.1. Explain with examples decay equations, alpha decay, beta decay and gamma decay. So, to achieve the learning outcomes, the student should know first what is radioactivity, second, structure of atom, third, formation of positive and negative ions, four, ionizing and non-ionizing radiation, fifth, three types of radioactive radiation, six, three types of decay equations, and seven, use of radiation decay. Let's begin our lesson with a short story. This is Ame. Ame is at hospital. One day, he walks around at hospital and found there is a room that has a warning symbol in front of the door. So, he decided to walk away from the room. What is the meaning of this warning symbol? A warning to protect people from being exposed to radioactivity. So, let's we do a recap about radioactivity. Radioactivity. What is meant by radioactivity? Radioactivity is a random and spontaneous decay process of an unstable nucleus by emitting radioactive radiation. Radioactive radiation consists of alpha radiation, beta radiation, and gamma ray. Before that, do you still remember the structure of atoms? Let's recall for what you have learned in Form 1. In the structure of atom, there are three subatomic particles. In the nucleus, we have proton, which are positively charged particle, neutron, that is neutral particle that is no charge. Outside the nucleus, around the orbit, we have electron, which are negatively charged particle. When the number of protons in an atom is the same as the number of its electrons, the atom is neutral. Next, we move on to the formation of positive ions and negative ions. When an atom loses or gains electrons, the atom becomes a charged particle known as ions. First, we go to positive ion or cation. Cation means an atom that loses electrons form a positive ions. For example, this is the formation of sodium ions. So basically, it is a sodium atom. So when it loses one electrons, it becomes sodium ion. Next, we go to negative ion, or we call as anion. An ion means an atom that gains electrons from a negative ion. For example, this is the formation of chloride ion. If you can see here, basically, it is a chlorine atom. So when it gains one electrons, it becomes chloride ion. So I hope that you are still remember and recall that you have learned in Form 1. Next, let me move on to the radiations. Radiation has ionizing radiation and non-ionizing radiation. Ionizing radiation, a type of high energy radiation that has enough energy to remove an electron, which are negative particle from an atom or molecule, causing it to become ionized. For example, we have neutral air molecules, but when the alpha particle comes across the neutral air molecules, it have energy to remove an electron from the molecule and become ionized air. Non-ionizing radiation, a type of low energy radiation that does not have enough energy to remove an electron from an atom or molecules. Next, we see the example of ionizing radiation and non-ionizing radiation. If you can see the diagram is a EMF wave. From your left side, we have non-ionizing radiations, which have a low energy. From your right side, we have ionizing radiation, which are high energy. The example is X-ray, gamma ray. For example, X-ray, which can penetrate our body and reveal picture of our bones. We can say that X-rays are ionizing, meaning that they have the unique capability to remove electrons from atoms and molecules in the matter through which they pass. Intense exposure to ionizing radiation may produce skin damage. Next, let me move on to the three types of radioactive radiation, which are alpha radiation, beta radiation, and gamma ray. So, next we go to the differences between three types of radioactive radiation. For the first type, nature characteristic. Alpha is helium nucleus. It contains 2 protons and 2 neutrons. Beta, it is high-speed electron. Gamma ray, it is electromagnetic wave. Alpha has a positive charge of particle. Beta has negative signs of charge of particle. Gamma is neutral. For the ionizing power, alpha has high ionizing power. Beta has moderate ionizing power. Gamma has low ionizing power. For the penetration power, alpha particle is easily stuck with paper, while beta particle can travel a bit further and stuck with aluminium. A gamma ray has different situation. It is a wave, no mass and no charge. In theory, wavelength travel in any material. Usually, of lead is used to reduce emission to a reasonable level. So, it means we need to be aware of gamma ray while looking at penetrating. Gamma ray is dangerous because it can travel much further. Next, we look at deflection by electric field. Electric field is the area around charges of object. It forms landscape for charged object gradually kills and balance to charge dimensions. It makes charge accelerate and move potential gradient. So, from the diagram, we can see that the alpha pulse accelerate to the negative plate. For the beta particles, they accelerate to the positive plate. But for the gamma that has no charge will not be affected electric landscape and continue straight pulse. Next, we go to deflection by magnetic fields. In between radioactive source, we have magnetic field. So, if you can see in the diagram, alpha particle will upwards, while gamma just straight away, beta particle will go downwards. Previously, we looked at radioactive radiation. So now, let's we look at what is meant by radioactive decay. Radioactive decay. It is a process in which an unstable nucleus becomes more stable by emitting radioactive radiations. This process is random and spontaneous. Okay, what this means by spontaneous? It means that they are not affected or influenced by temperature, pressure, or any physical factors. Next, we look at three types of decay equation for these three: alpha, beta, gamma. Alpha decay. Alpha particle is a helium nucleus which consists of 2 protons and 2 neutrons. During alpha decay, an unstable nucleus releases an alpha particle to become a more stable nucleus of a new element. The general equation for an alpha decay is as follows. Parent nucleus has proton number Z, while the nuclear number is A. So, after alpha decay, the daughter nucleus has proton number Z equal to -2 and nuclear number A -4. So, it will produce the alpha particle which is helium. The example is uranium-238. After the decay, it will become a new element which is thorium-234 and it will produce the helium nucleus alpha particle. Next, beta decay. Beta particle is a fast-moving electron. During beta decay, a neutron in unstable nucleus decomposes into one proton and one electron. General equation for beta decay is as follows. Parent nucleus has proton number Z, while the nucleon number A. After beta decay, the daughter nucleus has proton Z plus 1 and nucleon number does not change. The resulting proton remains in the nucleus while electron is emitted with high kinetic energy as beta particle. For the examples, we have thorium-234. So, after beta decay, we will produce new element which is protactinium-234 and will produce beta particle electron. How about gamma decay? Gamma rays are high frequency electromagnetic wave. During gamma decay, an unstable nucleus releases its excess energy to become more stable. The equations are as follows. Gamma rays have no mass and are neutral, no charge. After gamma decay, there are no charge in proton number and nucleon number for nucleus. The nucleus is less energetic after gamma decay. For example, we can see here is cobalt-60. Cobalt-60, before the decay, nucleus of cobalt is less stable. But after gamma decay, cobalt-60 nucleus of cobalt is more stable and we produce the gamma ray. Next, let's we go to the use of radiation decay. So, here is one example for each radioactive decay. Alpha is used as smoke detector. Because alpha is ionizing, a current flows in smoke detector. When smoke enters the detector, alpha particle cannot pass through and no current, so the alarm is sounds. For beta, it used as monitoring the thickness of metal sheets. If beta radiation detector detects too much beta radiations, this means that metal sheet is too thin. For gamma, it used as preservation of food such as fruits. Gamma rays are used in the preservation of food such as fruits to kill the bacteria. So, from the previous slides, it means that we already covered for today's lesson. To test your understanding, let's we do practice. First question, state the definition of radioactivity. So, the answer is radioactivity is a random and spontaneous decay process of an unstable nucleus by emitting radioactive radiation. Next, question 2. Uranium-238 emits an alpha particle and disintegrates into a thorium atom. State the nucleon number and proton number of the thorium isotope form. So, these are the questions as follow. So, the answer is nucleon number, it will be 234 and proton number 90. If you can see as the above equations, which means that during alpha decay, a radioactive atom uranium decay and emits an alpha particle. It means that uranium lost 2 neutrons and 2 protons and become thorium. So, I end my today lesson with thank you everyone for watching.